For decades, we have looked up at the night sky and asked if we are ready to leave this planet and colonize the solar system. The 2026 VAST-1 mission provides a practical answer. It is the first crewed flight to a private orbital outpost, utilizing a commercial rocket and capsule to reach a station independent of the International Space Station. The protocol starts with ascent. A recycled Falcon 9 rocket will lift off, proving that reliable, reusable launch vehicles can drive down the cost of human spaceflight. During the transit phase, a 4-person crew navigates toward their destination aboard the Crew Dragon capsule. The capsule then executes an automated docking sequence, connecting directly to Haven 1, the world's first purely commercial space station. This begins the habitation phase. The crew remains on board for up to 30 days, conducting dedicated research in microgravity. The return initiates with undocking, a controlled atmospheric reentry, and a safe ocean splashdown. What makes this architecture highly efficient is SpaceX's end-to-end vertical integration. They provide the spacesuits, run the emergency simulations, and conduct all astronaut training in-house, entirely independent of government agencies. By turning low Earth orbit into a routine, commercial transit route, they satisfy the absolute prerequisite for human survival deeper in the solar system. Between 2026 and 2028, the geographic scope of human operations expands outward to the lunar surface. Before any crewed landings attempt this journey, the Blue Ghost Mission 2 will touch down in 2026, acting as a robotic scout. This diagram illustrates exactly what Blue Ghost is looking for. Stereoscopic cameras will measure how the engine plume aggressively displaces the top layer of lunar regolith during descent. Mapping this surface erosion provides hard data on structural risks. It is a mandatory safety threshold that must be cleared before engineers can safely land thousands of tons of crewed architecture on the moon. That data feeds directly into Artemis 3 and 4. The vehicle chosen for those missions is the Starship Human Landing System, a 52-meter-tall structure of stainless steel. Because the crew cabin sits so high off the ground, astronauts will rely on a built-in 35-meter elevator just to lower themselves down to the lunar polar surface. Surviving the moon demand entirely new scales of mass and engineering. Ideas that were once confined to science fiction are now being forged into functional, load-bearing architecture. For Artemis 4, this architecture relies on the Gateway, a small space station positioned in a near-rectilinear halo orbit around the moon. The Orion capsule will launch from Earth and dock with the Gateway. Once secured, the crew will transfer through the station and board the waiting Starship for their descent. Operating a ship of this immense size requires solving the primary bottleneck of deep space transit, orbital refueling. This schematic demonstrates the process. 2 massive ships must dock tail to tail in the vacuum of space, establishing a secure connection to transfer cryogenic methane and liquid oxygen between their tanks. In microgravity, those liquids float unpredictably instead of settling at the bottom of the tanks. To force the propellant to depart Earth's orbit with the fuel reserves necessary for deep space transit. With these orbital logistics solved, the Lunar South Pole ceases to be a brief visiting spot, laying the groundwork for a permanent, nuclear-powered human colony. Once the infrastructure is proven in the Earth-Moon system, the focus pushes outward toward the deepest, most hostile frontiers of the solar system. In 2028, the Dragonfly mission will target Titan, Saturn's largest and most mysterious moon. Executing an interplanetary insertion to the outer solar system requires the immense thrust of the Falcon Heavy rocket. The payload is a car-sized nuclear-powered drone engineered specifically to navigate through Titan's incredibly thick, freezing, and hazy atmosphere. By flying over these alien dunes, the probe will search the hydrocarbon-rich environment for the chemical building blocks of life. And while robotic probes map the distant moons, the ultimate destination for human expansion remains the surface of Mars, waiting for the first uncrewed and eventually crewed flights of Starship. When we combine the robotic ingenuity of missions like Dragonfly with the sheer brute force of Starship, we see that humanity now possesses the physical tools to reach any corner of our solar system. Look closely at the present day, the continuous deployment of Starlink satellites and the rapid iteration of Starship flight tests. These missions represent the assembly of a standardized transport infrastructure designed to move tons of cargo and crew beyond Earth consistently. When you look at the stars tonight, You are seeing the specific coordinates of the outposts we are currently building. Our presence in the solar system is moving from observation to habitation. Subscribe and join us in discovering the next chapter of humanity.